I am never going to stop grinning like an idiot over how much I love our new intro music.
The intro video is pretty awesome. It's pretty awesome.
So good. It's so good. Michael, you don't know that we were gifted that. We had some folks come on to talk about Project Hummingbird, Ben and Valentine. And Ben had done this. He had made this for a different podcast that they had been on as well. And apparently it had no permanent home. And I was like, oh my God, it's mine forever if you'll let me. And they're like, yeah, have it. All yours.
I love it. I love it. It's like it's a really solid intro. Like that is like the epitome of professional right there. So I like it a lot.
Good. It's so good. And Ben apparently is the guitarist on it. So he himself did that.
Oh, that's cool.
Yes. Yeah.
That's neat.
So cool. So I tell everybody every episode we talk about our intro now because I love it. I don't know when that'll wear off. Probably never.
I love it. That's great.
Yeah. All right. So back to, like regularly scheduled acting like we're professionals here. Good morning, GitOpsians. Our episode today is about hosted control planes, also known as HyperShift. Michael is our guest. I work a lot with Michael. He's pretty awesome. Before we dive into that, we're just going to do some real quick announcements. The first one is, of course, the reminder that this is our last stream for a few weeks. We're going to have to skip a few because I do have that upcoming medical leave I mentioned. And to preempt the questions, no, I did not get hurt sword fighting. I fell off a skateboard. Sword fighting is much safer. So,
allegedly. Allegedly.
It so far has not dislocated any of my major joints. So we're going to say it's much safer thus far. Anyway, I should be back sometime in May, but then there's also Summit to be considered around. So we're still working exactly our final schedule out. So sometime towards the end of May, possibly beginning of June, we will be back. Other than that, KubeCon recap. KubeCon was excellent. The CNCF has posted the recordings now of the sessions. My session is included in that. I had a session on reliability for AI inference, which I don't even remember anything I said because I was so stressed because my co-presenter was so sick. I thought I was going to have to give his part of the presentation too. And this is a fun thing. I don't know if you've ever been through that. I ended up having to sit there during the presentation before ours, and I was restudying his pieces to make sure I could intelligently talk about all of the things on AI inference that he was supposed to talk about. So by the time we got on stage, I had forgotten everything I was going to say. I don't think it shows in the presentation, but I had cache refresh, totally dumped what I was expecting to talk about. I don't do speakers notes, so I had nothing to save me.
You don't do any hilarious speaker notes? Not any at all?
I don't even stand at the computer. I'm pacing.
Man, I mean, I'm a pacer too, but I just can't imagine going into something and not having anything written down at all. I'll look at the slide and be like, oh no.
Well, because I also don't read my slides, and I'll tell you that. I'm not going to read this to you. Take a picture. I am the worst. I'm the worst. But I try not to talk to people about things at KubeCon I couldn't tell you about at 3 a.m. with no sleep, because it's typically the equivalent of my 3 a.m. So anyway, but those recordings are up. And there are a lot of really great recordings. It was a really great KubeCon. There were so many sessions I wanted to go to that I didn't get to go to. I'm planning to watch through recordings. 10 of 10 recommend. And it was the largest KubeCon yet, which we think.
Oh, we lost Hill.
Yep.
The internet today. All of us have had this happen. All of us have had this happen. It was my turn. Anyway, there were over 13,500 people at KubeCon this time. It was the biggest KubeCon.
Yeah.
So awesome. That's it. I don't think I had any other announcements because we don't have any other major releases that have happened at Red Hat this month, Johnny.
Yeah, not that I can think of. ACM 216. Yeah, just normal stuff.
Normal stuff. Yeah. 422 is coming soon. That should have some pretty exciting stuff in it when it gets there, but you'll cover that on the Ask an OpenShift Expert stream most likely. So yeah, some of the exciting things that are coming in 422 are directly related to hosted control planes and HyperShift, and that is why Michael is here, is to tell us what the heck is HyperShift and how do people use it?
Yeah, I mean, I really loved the title of the episode of the out of control planes. I think, when we really distill it down, right, HyperShift and the hosted control planes effort is just the ability to, instead of having a set control plane for an individual cluster that's set on individual nodes, simply taking that and abstracting it away, right? And so we have so many opportunities to do things that we couldn't have done before from an optimization perspective, from a resource utilization piece. And that saves customers money. It makes things a lot easier for them to use. But it also gives us an opportunity to provide way more fault tolerance, way more scalability to customers. It really also changes the dynamic, especially in our managed cloud service offerings like Azure Red Hat OpenShift and Red Hat OpenShift service on AWS. It really allows us to kind of change our paradigm of the way that we actually manage these environments. And not to mention, it's a great place for us to be able to deliver features faster to customers because we're no longer individually waiting on OpenShift versions for things. We're able to roll them out through the HyperShift operator and through the hosted control planes feature itself. And that provides a lot of flexibility for our end users.
So, and I realize I totally forgot to have you introduce yourself, Michael, so we can go back and do that if you feel like you missed that.
Sure. Well, I'm Michael. I serve as the America's Cloud Services Tech Sales Leader at Red Hat. I've been working with Red Hat's cloud services and OpenShift in general for a long time, since before it was even based on Kubernetes. Back for anybody who has PTSD about that, when it was gears and cartridges. It's been a long time since that has happened, but I've gotten to watch and participate in OpenShift as it has progressed from that early days of pre-container, pre-Kubernetes into an application platform that's built based on automated operations and operators. We've gotten to see kind of the evolution of that as it goes. So now I lead a team of architects here at Red Hat that specialize in our cloud services. I also work with a lot of our strategic customers and driving their business forward with our products and services. And I also get to moonlight occasionally with our SRE friends like Hill. And it's a lot of fun to be able to be involved in such a fast-paced ecosystem that we operate in. Not to mention all of the evolution that's going on is really fun to be a part of. Really fun to watch. Plus, this is my first podcast ever, so it's a little bit of a stretch for me. But I'm excited to be here. Really grateful for you and Jonny having me on. So thanks for having me today.
Yeah, no, it's shame on me for not inviting you sooner. That's my bad. Yeah, like Michael said, he is an occasional foxhole buddy on some very interesting incidents. My favorite is from, okay, actually there's a few really good ones. But my favorite example of one is there was January of 2025. There was an incident where I was on call and I ended up having to spend 16 hours. And Michael, at a certain point, you joined. I remember
this.
And remember, like, I was just not even human anymore.
Oh, I remember that entirely. And I believe that was actually right when your new boss's boss started. That was like his first incident ever. Yeah.
Oh, yeah.
And
yeah,
I remember being like, yikes, this is we're
You're welcome, baby.
in the deep end. And he was on call too, I think, as the manager then too.
He wasn't. He just he just happened to see
he just showed up.
And showed up. Yeah, he was doing some onboarding. Oh gosh.
Oh, stuff. I mean, we've been in a lot of those situations. It's pretty interesting to see. Like because previously I was an engineer before I was like in sales as a tech salesperson, and so it's always fun to be a part of those until it's not, and then it's like, oh Lord, what did I get myself into?
Yeah.
There have been a few times where we've had situations where it's like, we just need someone to bounce ideas off of in those moments. And it's a lot of fun though. It shows like, I think from my perspective, like there's so much knowledge that we all individually have. And so like getting to like be able to collaborate and learn more about that is so very valuable. I also think, like we get to learn so much in those moments. And also like, I know once I get out of those, just like I know when you got out of that, it was like, well, got to be back online in a few hours for my next call session. So it's it's always an interesting time in SRE land.
It is, yeah. But you're definitely one of my favorite foxhole buddies. So thank you for that. That's what I say every time we're in something like that. It's like, these are your foxhole buddies. Like, what's, you gotta trust. Right. You gotta have trust and humor, right? The number of times we've been sitting there cracking jokes while we are like, what is even happening? But it's also, we learn a lot about what the customers are actually doing in those moments.
Absolutely. Yeah. I think, that's one of the things that is really interesting and actually really special about my job is getting to work really closely with customers, but also really closely with the people who are building and engineering our products is really, really neat. I think it's so hard when we're operating at the scale that we operate our services at to really be able to understand what customers are actually doing with it. And we've made a really good effort lately, especially to like work collaboratively with our customers to really identify like, how do we go through kind of the customer shoes and the challenges that they're facing as they're using this. In fact, if you like look at some of the beginning parts of the HyperShift effort and the hosted control planes effort, it's really been designed to be a customer specific engagement model. Like, we have been listening and constantly iterating on these features and the things that are available specifically for the customers that are using them. And it's really neat and honestly really rewarding to see that. In many ways, it's especially cool, like, to be able to see the things that sometimes you don't even realize are actually powered by hosted control planes and OpenShift and our managed services in just like in your day-to-day life, the things that you're doing that you don't even realize. It's like, wow, like I had no idea that that these solutions are actually running on top of the things that we get to work on every day. So it's really cool. And I think it presents a really unique challenge, right? When we talk about like all of these things that customers are doing, it's not that every customer is the same, because in fact, many customers are like widely different. We've seen customers at every scale and every kind of configuration possible, it feels like. And that's the challenge that we're always facing. Actually, it's one of the big drivers behind the hosted control planes effort is we want to make it so that customers can have a lot more control over the things that they're doing without the need to kind of have a bunch of unnecessary guardrails. It's a really neat effort to be able to actually say, hey, we want to give you back control of things that you've been asking for. And by doing so, we actually kind of make their lives easier, but we also make our lives and SRE's lives a lot easier, because a lot less toil, a lot less headache, and a lot less confusion. Like, our customers are able to actually say, what can I do? How do I do this? And we can really drive that forward. So I think that's really neat.
Yeah, it really provides a lot of I specifically want to talk about this as it pertains to like the networking stack within OpenShift. So when we're doing the managed services, in order for us to successfully have a managed service, we need a really specific networking stack. This allows us to meet security and compliance requirements, all the way up through FedRAMP High and others. But how we need to do that in order to achieve that doesn't always align with how a customer wants to do their networking stack for their specific potentially compliance requirements. That could be, or just preference, but maybe a little mixture of both, how they prefer to meet their compliance requirements, etc. And networking is honestly the number one source of friction that we have. So the coolest thing to me, one of the coolest things to me about the hosted control plane implementation, both within the managed services and actually just as like, even if you were to do hosted control planes, which there are people who are.
Absolutely.
That's there. It's open source. Have at, enjoy. Is that you can like still have that exact thing. You can have, Cilium over here while we're doing whatever we need to do in our end of the thing in order for us to meet what we need to meet for that kind of level of service that our customers are expecting without getting in the way of them doing the needful.
Yeah, I mean, we have customers, and that goes a lot towards like the bringing customers with us, but also helping them achieve kind of the way that they want to do things. We've always been, Red Hat in general has been somewhat opinionated as we actually go through like delivering and deploying OpenShift. So it's not any like it's not that foreign for us to be like, hey, we suggest using these components and things like that, and you can rip and replace these things. But oftentimes it created a lot of challenges. Networking is a great example of that, right? It's like our ability to validate and test and configure our environments to support these other CNIs, these tools like that, for example, use like eBPF, right? Which is a great tool, but it also provides us a significant amount of complexity that we have to constantly engineer for. And so when we actually look at HyperShift, there's kind of two different pieces of the puzzle. So like first piece is like, how do we provide connectivity from the hosted control plane itself into the like workers themselves, the actual compute nodes? And I think it's actually a really neat thing to talk about, because one of the things that I think a lot of people don't realize is that in those moments, you've actually got a lot of different networking pieces involved, but all of them are abstracted away from the underlying usage. So like, for example, in AWS, we use the AWS Private Link service as the mechanism to interconnect the control plane and the actual compute nodes themselves. The reason that that's really neat, though, is because essentially when we're talking about how customers connect to that endpoint, it's not anything different. So like if we're in a private cluster, they just connect to that VPC endpoint inside of their VPC, and it's just another endpoint for them to connect to. But the thing that I think is the most neat about it is we also have the ability to create other VPC endpoints outside of that account. So for example, if you have a customer who's using like Argo CD, for example, to manage their GitOps environment, right? So they could be using that, and inside of their Argo CD environment, you can create another VPC endpoint that allows them API server access to their HyperShift cluster, to their hosted control plane cluster, without any additional network connectivity. So there's no like VPC pairing, there's no transit gateways. And what it does is it provides customers a multitude of ways to actually configure and deploy those environments. And it also provides a way for us to ensure security and stability of the platform, as we know that this is the way that we're responsible for maintaining these endpoints. And we use native cloud services like AWS Private Link, right? And like private endpoints inside of Azure. We're developing our solutions based on those kind of needs. And we've heard from customers that they want to be able to do what they want, essentially, whether that's run their own CNI, right? Cilium, we've worked a lot with Isovalent to make sure that Cilium works well in hosted control planes and is a certified platform to deploy on. We're doing that as well for the future Aero hosted control plane offering. And so we've done a lot of work around that because we want to give customers the flexibility of choice, while also making sure that we are confident in what we can actually deliver to the customers themselves, so that we can feel comfortable maintaining and supporting it and driving SLAs, SLOs, and things like that for our underlying customers.
Yeah, I think when we talk about like OpenShift, when people have asked me to describe OpenShift, I've always been like, it's an opinionated enterprise-ready Kubernetes, right? But the opinions, like you need to know what those are. Here is where this shift to hosted control planes, it starts taking all of our opinions and making them purely additive. It's no longer an either or like, you know, there's not that same trade-off equation that you may have had, that cost benefit like balance sheet that you would need to do when considering our opinions. It actually just starts making them purely additive and kind of like you take them or leave them, but they're there if you want them. And that makes it like, I think, significantly more powerful than it was before. And I will also say, like, if we look at the history of the opinions in OpenShift, a lot of them predate there being an actual standard within the Kubernetes project itself. And so we have had to go back and start making changes to OpenShift to match the Kubernetes standard if it didn't evolve in the same way we've evolved our product. And that's also, I think, a really cool thing that we do, although it is still something that has a little bit of friction and pain points, obviously, for customers who, a lot of customers are using OpenShift as part of their overall story and not necessarily not using GKE or AKS or EKS. I get my acronyms mixed up. And so that I think is what hosted control planes as the next generation like really is like we still have our opinions. They're still there. You can still use them, but now they're purely additive.
Yeah.
I do want to take a moment because our Hope 9 asked a question a while ago, and we love our Hope 9. He's our absolute favorite person. So Michael, this question is to you. Also, fun fact, PVC and VPC, because I am dyslexic, I frequently type the wrong one, and this causes absolute chaos in my communications. But I think most people who've worked with me a long time are now used to it and are able to use their context clues. But anyway, let me see if I can read this without messing it up. So longtime hosted control planes fan, still ultra noob, is hosted control planes pods able to self-heal at CD if the persistent volume claim it relies on gets corrupted?
Yeah, so there the answer is
it's 3 etcds and a trench coat.
That's right. The answer to this is kind of complicated, right? There's a multitude of ways to actually handle this. And there's not so like an individual corrupted volume is one of the things that generally speaking has to have some sort of manual remediation that comes into play. Now, obviously, like etcd, we're talking about quorum, we're talking about all of the things that make up kind of a resilient distributed system. So losing one of those instances itself doesn't necessarily mean that you'll lose your cluster, right? Instead, you just simply lose that redundancy of that individual node. A new leader gets elected by the remaining 2, and then you continue operating. But unfortunately, like there's still some manual requirements around how we actually self-heal etcd. Now, there's a lot of automated operations around how we self-heal that through other activities, right? Not necessarily losing a PDC, but other operations and other just general. I mean, we have situations where, for example, etcd gets filled up and you have to defrag etcd. There's automated operations that help to reduce a lot of that toil from an operations perspective. It's also important to remember, like, etcd is one of those components that we have a pretty good understanding of what the limitations are around it. And so we've developed a significant amount of alerting and understanding around how that actually works. I think the other piece of that is like backups is so important in these ecosystems. We talk about how do we effectively back up, restore, and ensure that we are ensuring the stability and availability of those underlying platforms. So we have done a lot of work around that. We continue to do a lot of work around that in our managed cloud services. So still a little manual work when we come to like losing volumes or things like that. But it's still an overall an overall better process, in my opinion, than just simply having to recycle an entire node itself. Instead, you've got one component that just needs to be resolved and addressed, as opposed to I need to possibly consider restarting the entire node. I need to possibly consider blowing away that node or allowing like the control plane machine set operator to blow away that node and replace it. There's a lot of risk when doing so because you're also decreasing API server availability, you're decreasing scheduler availability, all of those things, that those components that live on those nodes in hosted control planes and in HyperShift. The concept is those are distributed across a bunch of different nodes. So individual node failures don't have the same limitations that they do in standalone OpenShift. But more importantly, if you have an individual component failure, it doesn't mean that you also have all the other components that go down as well with it. So hopefully that's a general answer around that.
It also is like which etcd, right? Because when I make the joke, it's 3 etcds in a trench coat. Which one of the etcd instances and their 3 what do you call it? The 3 thingies.
The controllers,
like the individual pods that make the quorum. There's a word I'm looking for. Whatever, you know what I'm talking about. You have the 3 etcd pods, right? The 3 for the etcd like overall deployment, right? And you have each of those 3 is that makes the agreement. The fact that I cannot come up with this word is really irritating me because like this is the same concept that works in Kafka as well, and like any of these other types.
An arbiter.
Of things. Yes.
Is that what you're thinking of? Okay.
I think that's the word. That sounds like that's correct.
Okay. Anyway, there you go.
You know, words are hard. so I was like, words are hard. Technical words are harder. Right. So we have those for the actual like control plane, hosted control plane itself, right? But then also, where is the hosted control plane running? Well, the hosted control plane is running on a Kubernetes cluster, right?
That's right.
So there's etcd there as well. And if my memory serves, and I haven't looked at this in a good while, I believe on the actual worker nodes that customers have, there's another etcd.
There's not. There's not normally. No.
Not normally. Okay, then maybe it was the now defunct other cluster that we were talking about. Anyway, there used to be 3 etcds, and I was like, it's 3 etcds in a trench coat, but I think now it's 2 etcds in a trench coat, which is significantly better. But anyway, yeah, so it does also a little bit depend on which etcd. Like Michael said, we mostly have this automated. It's mostly the same kind of regardless. However, if there is some sort of like serious operational thing, with like the main cluster etcd, that means something like the way the team engage and handles and mitigates for that is really different. And that's actually where the power of like it being a hosted control plane is, because if there's some sort of instability going on with the host, you migrate them to another host.
That's right. Exactly. And one of the great benefits of that too, that I think is probably like, we have seen situations recently where AWS has lost an availability zone. And so even though we have, in those cases like that, you lose that availability zone, you can't just magically reschedule those resources over into another availability zone. But we still see a lot more resilience in those environments because of the ability to distribute that across those different data centers. So like when we talk about resiliency and building fault tolerance, hosted control plane is so much more fault tolerant than a standalone OpenShift cluster, solely because you're not talking about 3 nodes, you're talking about hundreds of nodes, right? And our ability to essentially have a widespread view of those, right? It's the benefits of Kubernetes just being applied to the greater construct of the control plane, as opposed to just having individual nodes that are dedicated and responsible for it. So I think that's really, really valuable for sure.
Yeah, exactly. And so that also there was something that was talked about on this stream a while ago about customers who want to have like one gargantuan cluster, 1,000 node cluster where every single thing runs, right? Dev, tests, staging. Johnny's laughing because he remembers my reaction was like, "Oh God, don't you dare!" I didn't say, "Oh God, don't you dare." I said, "Oh God, be really careful," because of like, some of those cluster resources that are really finite, where the concern is not really the workers themselves, but it's like what it would do to the control plane and what that instability to the control plane could mean for everything overall. That concern goes away with hosted control planes. I care a lot less. I mean, I still think you shouldn't run production workloads on the same nodes as you run your scale testing on. That's a great way to cause. We've seen that happen. We've seen multiple customers give themselves TCP socket exhaustion with their production workloads through that. I've seen it so many times. I can now correctly diagnose this without looking at a single log line. If you describe
we just know the behavior now. Yeah.
If you describe the cluster behavior, I can tell you sounds like this. Run this command, and whether or not I'm correct is immediately obvious. It's actually now it's kind of just a joke. It's just funny. This is my best party trick. So still be careful.
Yeah.
Isolate your workloads as best you can, but that concern about those things that are shared across an entire resource, CPU is shared across an entire cluster, actually, even though you have like node and pod specific boundaries, you are not going to have to worry the same way about if you do mess up a configuration that your control plane is going to be impacted. That isolation allows you to scale the way you want to for your organization.
And I think the other thing too that's really valuable in that, right? So we've got resource auto scaling, for example, in Rosa with hosted control planes. We built resource-based auto scaling that actually is built into the cluster that allows your control plane to scale appropriately based on your individual. Like, let's say you're like driving a lot of traffic to your API server, right? That needs to be scaled vertically, right? We built in the ability to do that. The other thing that I think is probably important, though, one of the things that would have driven people before to saying, I need this big cluster to host all of my workloads, is because ultimately those 3 control plane nodes and 2 to 3 infrastructure nodes, those are really expensive, right? So we look at compute costs alone, right? That's 10, 13, $15,000 in compute costs. I mean, for a very large cluster, that's even more, right? As we like look to scale those resources up. And so the great news is in that our hosted control plane offerings, you don't have to worry about that. There's no infrastructure costs for running your control plane. In fact, all of that is from Red Hat's perspective, like it's part of the service offering. So whether or not, like if we actually look at like how that actually ends up working, right? We have a lot of benefit in all of this to be able to say, hey, you want to run your 3 separate clusters. There's no real additional infrastructure overhead to do so. And so that provides a lot of benefit. The other thing too is that we've replaced all that infrastructure cost with simply a 25 cent an hour control plane fee. And that is significantly cheaper. In fact, like most customers who'd move from a standalone OpenShift into a hosted control plane architecture in our cloud services save anywhere from like $9,000 to $13,000 a year, depending on like their average cloud discount and what they're actually the size of those control plane nodes. So that adds up really fast. We have a customer who has 500 clusters, right? Let's say they save on average $10,000 a year, right? We're talking that's a meaningful sum of money to a business. That is like an actual, like real amount of dollars. Even like customers with 3, 5 clusters save a lot of money by doing that. And so there's a lot of value in cloud services there, and running hosted control planes. Not to mention the other thing that I think is probably important too in that is like there are always going to be things that are cluster context specific. So like, for example, in your cluster, are you running the same operator in dev and production? Are you running the same version? If not, like what is the challenge there with CRDs and things like that? We have all of these challenges. And a lot of times customers are apprehensive about saying, I can't afford to spend $15,000 more a year to run multiple environments. I can have 2, right? And it's for us, it's now saying, well, the great news is that you don't have to worry about that anymore because the control plane itself doesn't end up in the customer's account. So it provides a lot of flexibility there. And then we on the Red Hat side can bin pack and effectively manage and scale the service appropriately, which I think is the other value benefit is like we are getting the economies of scale and the efficiencies of scale. I think that's a really, really big really big thing. So,
well, one thing too is like you're talking about financial savings, and like my team uses HyperShift. I'm not going to say exclusively, but pretty close to exclusively, and we had like a 40% cloud savings, right? But it's time, right? So like there's this a significant amount of time that you gain from using something like HyperShift or any of these like hosted control planes. Where like, if you deploy an OpenShift cluster either through Hive or OpenShift install or whatever, mechanism it is, it's a 30+ minute process, right? With hosted control planes, I love the name HyperShift so much that it bothers me that they went to hosted.
We're all with you on this HyperShift train here, Johnny.
Yeah. Anyways, it's a great name. They should have just left it. Anyways,
the operator is still called HyperShift. So
yes,
I mean, that's the component that does everything. So calling it HyperShift is not inaccurate. You're just referring to the specific component.
That's not wrong. Yeah, you're right.
It's not wrong.
But yeah, it takes 10 to 15 minutes, and so like we're doing a lot of work in my team right now with DR, disaster recovery. So like to test the things that we're doing, we'll spin up a cluster. We'll spin up a couple of clusters, apply our DR automation, and then tear it down and then redo it. If you're doing this the old school way, I mean, it's an hour plus just to get your clusters up and then apply the automation.
Or you need to already have it there, ready to have the load balancer swapped to it. So you're just paying. And there are customers that do that because their applications are so critical and can have absolutely no downtime. Actually, one of our Foxhole incidents, Michael, was a really impressive customer with an amazing DR. Oh God, it was amazing. It was quick. I was so impressed. I obviously can never tell anybody besides like Michael and myself who worked on this, which customer this was. Especially because in Aero, we're not even supposed to know who our customers are. That information is completely abstracted from us. I could not tell you if somebody is important, like big, financial institution or like tiny little research thing doing nothing mission critical. I have no idea. Makes no difference to me either. I treat them all the same. But I do happen to know which customer this is. So Michael and I get to just have this shared secret context. And Michael will remember how much I was like, oh my God, these guys are so cool.
Yeah. Yeah. I mean, we've got a lot of customers doing cool things. I think, Johnny, to your point, right? Like time is money, right? In these customers, right? The ability to spin up those clusters quickly. I think the other thing that's really cool about hosted control planes is, in my opinion, like our ability to automate cluster creation and lifecycle management in ways, talking about GitOps, is through things like Cluster API. We've got our Cluster API provider for AWS and Cluster API provider for Azure for the inevitable ARO hosted control plane offering that allows us to do programmatic control and declarative control of our clusters lifecycles in ways that our customers are already asking for and using today. So the ability to create a cluster using Cluster API, manage that resource and that the underlying lifecycle of that cluster in an automated fashion is huge. We can also then take that and use things like Red Hat Advanced Cluster Management for Kubernetes that allow us to effectively understand and mitigate kind of some of the challenges that we see with customers in terms of how long it takes to get running into an environment. We can apply a blueprint and get customers like from zero to hero very fast because of all of those benefits. So that saves time, it saves operational overhead, it saves customers, honestly, just a lot of heartache. We struggle a lot when we talk about like how we grow our business in terms of how do we make it easy for customers to use our service offerings. And so the way that we talk about that is we want to make our hosted control planes offerings as easy as possible to use, as prescriptive as possible to start, but with the flexibility for customers to be as opinionated themselves as they want to be. Like, I want to use X, Y, and Z. And the even more complex part about that is we are wanting the customer to do that, like Hill is talking about in the chat. We want to be able to do that without touching or looking at customer workloads, because in our managed service offerings, we don't want to see customer data. We don't want to have access to it. We don't want to touch it. We don't want to understand it. We want to know nothing about it. The reality for us is we want to manage these environments, and all of them are production to us. Whether you're using clusters like this development environment, we don't know, and truthfully, we don't care. Our perspective is whether you're a customer that is running in mission critical production workloads or just a cluster to play around in, they're all production to us. And we do that specifically because we want to be able to ensure that our fleet is run in a way that's scalable. Regardless of what customers are doing, that's irrelevant to us. Instead, what matters the most is that we need to be able to identify problems quickly that would impact your customer, ensure stability, reliability, and security, and then make sure that we're giving customers a platform that they can trust that is going to support their individual goals. Not to mention that gives them all these tools to be successful, whether that's GitOps, whether that's virtualization, whether that's AI, right? All of these tools are really what makes OpenShift in itself different, because OpenShift isn't just Kubernetes. It's really an application platform that we can give customers to actually build their applications, deploy their workloads, and get them to a point that is, I am working on my next generation applications next to my legacy applications, next to my, my containerized, my virtualized, et cetera, workloads. All of that really comes together, and HyperShift provides a great place for customers to actually operate within, because it gives them that flexibility and all of the tooling and everything that comes along with OpenShift, but in a little bit of a smaller package and a lot more resilient of a package, in my opinion.
Yeah, and I think when they moved to STS, I think it really, like when they went from like the traditional AWS credentials that you were passing through and went to STS, I think that really kind of solidified like the approach that they were taking from a security standpoint, and like really starting to put boundaries around these nodes and these clusters and stuff like that. And it was a little bit of a growing pain, trying to get some of the Red Hat certified operators to use STS, and then there was like this like weird kind of like imbalance of what was supported and what wasn't. But obviously maturity and stuff like that has gone along, and I don't know if there's anything now that doesn't work on HyperShift anymore.
Yeah, I mean, the reality is that we all know that that long-lived credentials in any of our ecosystems are bad news bears, right? We don't want customers to be using long-term credentials. We don't, I mean, for anything, right? Whether you're accessing AWS or Azure or Google services, whether you're accessing databases and things like that. In no uncertain circumstances should you attempt to use long-lived credentials for these things, because ultimately it is so difficult to control the life cycle of them. We have seen instances where you have these like the Trivi hack recently, where you have credentials that are being exfiltrated from CI systems through like supply chain attacks. Ultimately, the only way to avoid those attacks is to use short-term credentials that don't last longer than you individually need them. So when we talk about, like, one of the great benefits of hosted control planes is we have eliminated the ability to use those like long-term credentials. Everything is AWS STS or is managed identity, workload identity from Azure, or workload identity federation for Google. All of those pieces, short-term credentials that are pod identity specific. So instead of us having situations where my pod is using the node's identity, which gives me all of this access, or it's even worse, it's IP restricted or something like that, right? Instead, we're looking at this in a comprehensive way. OpenShift was actually really early onto the scene, going back earlier to what Hill said about trying to build security into the underlying platform. I remember when we were talking about security context constraints and the value that added to the platform, because it provided defense in depth, right? It was like this idea of, we don't run privileged containers. We don't run as user zero, right? We don't do all of these things. We take into account things like SE Linux context as we're actually building these environments. And so all of that was something that Red Hat built in. And even in the Kubernetes community, right? We had pod security policies. Now we have pod security admission, right? And Red Hat has worked really hard to make sure that the work that we are doing inside of OpenShift is compatible with the greater community. But we've done the same thing in the cloud ecosystem. Things that we used to do from the cloud credential operator in OpenShift is now simply done through secondary controls in our cloud providers, right? The ability to use things like the OpenID Connect protocol to actually connect to cloud providers safely and securely, and secure resources that way. In fact, a member of my team, Kevin Collins, just actually went through this. We have an OpenShift dedicated environment on Google Cloud that needed to access an Azure Cosmos DB. And so we actually used the identity provider in OpenShift dedicated and inside of Google to access that resource using short-term workload identity credentials. And so the ability to do that is not just limited to individual cloud provider services. We're talking about cross-cloud opportunities. We're talking about the ability to provide more end-to-end security and reduce the attack surface of our environments. We've done so much work around that in OpenShift from like a granularity perspective, right? So we've reduced the attack surface of the operating system through Relic Core OS. We've got security context constraints from the runtime operation perspective. We've got ACS for making sure that runtime and image security is taken care of, right? And then we've got the vulnerability management and things that Red Hat has really focused on. I think all of that comes together in this cloud ecosystem of how do we use short-term credentials? How do we use like very granular, like specific permissions? I think all of that is really valuable.
So we have a topic suggestion from our Hope 9, which is about token expiry scenarios, like consequences and prerequisites. I will say, like, the difference with a token compared to a credential is, like, it's very easy to get a refresh on demand. If for some reason an automatic refresh doesn't happen, generating that refresh on demand is actually, honestly, technically how they're really mostly used. Because a lot of them only live about 15 minutes. So you really mint them when you need them and then kill them when you don't, or let them auto expire with it when you don't. So at least a lot of what I've seen, I know it's not universal, but a lot of what I've seen, that's how we're doing it. It's just, and I think there is several upstream, like Kubernetes, CNCF ecosystem things that do this as well. I feel like I saw a talk about this KubeCon London that I was like tip of my tongue at all. When I stop thinking about it, I'll remember. But yeah, a lot of them. a lot of it is time bound, right? Auto expire. You can deliberately also cancel one as well. Those with the JWT tokens, both of those mechanisms exist. And then you just kind of only mint them when you need them, so they're just not there when you don't.
Yeah, and I mean, ultimately, we see. I think there's actually two really interesting points. One of these actually ties in really well. So, like the like default pod identity lifecycle, I think is an hour for cloud service tokens, but obviously, like you can recycle those on demand. You can regenerate them. Also, the other thing is you can control that. So there's flexibility to say I want tokens for a shorter period of time or a longer period of time, depending on what you need. But the other piece of this that I think is unique is we've developed inside of the hosted control plane offering, the ability to use an external authentication provider. If you have been familiar with OpenShift for a long time, you are probably used to our OAuth server that actually provides authentication authorization services for the cluster itself. Provides that for the API server. It allows you to connect through like the OCCLI, for example, the API, as well as essentially being a middleman to your underlying identity provider externally. So like, for example, if I'm using Microsoft Entra ID, and that's how I log in using single sign-on to my services for my business or my enterprise, right? I can configure that to interact with my OAuth server and connect. Well, external authentication changes that. Instead, there is no more OAuth server inside of OpenShift. We actually have removed it entirely. And we've replaced it instead with direct authentication to underlying OIDC providers. So the ability to use the OpenID Connect protocol directly with, say, Microsoft Entra ID or Okta or Insert X OpenID Connect provider. And the benefit of that, and something that I think is really cool, is twofold. One is it allows your identity provider to actually maintain credential token management. So in the event, let's say, for example, tomorrow Hilliary gets fired, and in this environment where she's working, all of a sudden she gets fired. Well, her token is invalidated immediately because she's been removed from the identity provider. Whereas in the OAuth server, it would take time for that session to time out. So we automatically get a security benefit from that. The other thing that's really cool is that you have the ability to do service-to-service based authentication to the API server itself. So it's really beneficial to actually be able to address some of the challenges that we've seen with like using authentication externally through the external authentication process. So that's something in Arrow HCP. It's our default path, and in our Rosa hosted control plane offering, it's optional but recommended. And I think there's a lot of value in that. So I think that's definitely a pretty big benefit to our hosted control plane offerings, and it's something that I think is really neat. It's an evolution that we had not previously taken advantage of internally.
Yeah, and it's really it's one of those things too where having that as like the starting default position in the hosted control planes is really it's very nice, I will say, for us on the SRE side internally as well, because there is only one set of credential types to care about. Whereas when we look at the original Azure Red Hat OpenShift offering, which has been around for, I don't know, about 6 years now, almost 6 years. Maybe longer, yeah. That's from before these technologies were in place. And we do have customers that have been with us that long. And unfortunately, because of the architectural incompatibilities, they're kind of stuck. We're doing other things to keep the highest level of security that we can, given the situation. But they are stuck with that old method of longer lived credentials. Now, those credentials don't live forever. Obviously, they still get rotated. But it's not that on-demand minting, incredibly short-lived ability to just like kill it off and not need it sometimes, right? None of those niceties and architectural evolutions exist. And the only way for customers to capitalize it is, unfortunately, they have to migrate. Now, ideally, I think we would like them to migrate to hosted control planes when it's there, as that way they continue to get all of the niceties that will continue to happen with this next generation architecture. In Azure Red Hat OpenShift, there are no 311 lurkers. mostly because I don't think we ever had that as an
We did.
option. And
We
did we?
Oh yeah. Yeah.
Well, not for this current resource provider. This current resource provider.
Not for the current RP. No. Correct. That was the original. Yeah.
The original, yes. Yes, that is true. Sorry, we made a big architectural shift. So in our service, there are no 311. But there are some customers that are still running clusters that are very much technically out of support. I mean, that said, anything happens, we'll go fix it, but they frequently don't have anything go wrong, which is also very interesting. But again, we can see when a cluster was born, like what version it was born on, and like compared to what version it's running. So we also know that we have many customers running current versions of OpenShift that have been with us since around like 4.4. That is a not small number of our fleet, and love these people, absolutely adore them. Thank you so much, right? But you know, I unfortunately there's still limit, even though they've been updating. There are just like base level architectural limitations to the benefits they can get that are in terms of security and compliance that will ultimately necessitate them moving to hosted control planes. And that's why Jonny's team, the validated patterns team, is definitely 100% totally going to help build a migration toolbox, right, Jonny? Right, Jonny?
Yeah.
Perfect.
Demos tomorrow. Yeah, demos tomorrow.
Easy, yeah. Exactly.
That's great.
This is actually
I can't wait.
about a lot. Yeah. We talk about this a lot, Jonny and I. Like, we just need to sit down and do this.
I think there is, it's funny you talk about the incompatibilities between these platforms. Ultimately, like we see this so much, right? Is we even see challenges with those clusters that are born on like 4.4, 4.6, 4.7, right? That we still use those boot images as we go along, right? And so it's like, we've made architectural changes to be able to address that inside of hosted control planes, so that doesn't happen anymore. That also provides a lot of flexibility in things like upgrades and greater management of those environments for customers. So our ability to actually run different resources is a lot different. But there's always going to be the cruft of old versions. Tech debt is real. I am hopeful that we will see a solid path towards addressing some of that as we go. Also, one of the things we see, obviously, is customers actually like look to modernize their platforms and use more modern solutions. The ability to fail to another cluster to migrate becomes a lot simpler. And in fact, we talk about this where instead of having customers focused on like, okay, I need to do this big platform migration, I need to do all this work to migrate A to B, when it's a no-op for most of them because they have already built the solid foundation that they're operating on together with OpenShift. Moving from one platform of OpenShift to another platform of OpenShift is all very similar constructs. And so we get a lot of value in that for our customers. And I'm so excited to see Jonny's demo. I'm gonna just gonna put that on my calendar to watch.
Yeah, you should. It's gonna be amazing. It'll be the best you've ever seen.
You know, actually, frankly speaking, this is like you say, it's not that. If you're already, well, I mean, and a lot of our customers are actually really good at this. A lot of our customers do already use GitOps. If you're already using GitOps, it's kind of, I'm in a high level armchair. This is not this simple, but it's basically adding another destination pointer. And then once those things are up and running, then it's like then add the networking path to slowly start moving the traffic from the original location to the new location until 100% of traffic is rerouted. And then you should just be up and going. The biggest challenge for this is, in fact, if you have a database involved, a database that is on cluster involved. That is the biggest challenge that you're going to have to do because you're going to have to do some database replication, and then you're going to have to change where the reads and the writes happen, and you're going to have to migrate that. We've solved, as an industry, we've solved these problems before. I've gone through that exact type of failover in virtual machine environments. Many times over my years that I don't care to talk about in the industry. So they're annoying problems, but they are solved problems. It is just sort of a matter of organization and project managing the execution. It's like I said, very high level. It's easy, asterisk, caveat, whatever. but it's a relatively solved problem.
Yeah, I mean, we put a lot of effort into making it easier for customers to be able to migrate things, whether or not they're using GitOps. Honestly, like using things like the migration toolkit for applications, and using Valero and the OpenShift APIs for data protection. Right, we've done a lot of work around those pieces to try and make it easier to back up, restore, migrate your workloads. There are always challenges, especially as we talk about like trying to get into no downtime upgrades. No downtime migrations, and the ability to do that. Also, the greater challenges that exist with different workloads. I mean, I guess the kind of stability that those platforms require, whether it's databases, messaging, things like that have end-to-end needs or are taken advantage of. It's still a challenge to be able to actually migrate everything seamlessly without downtime, which is in many customers' cases an important requirement.
Yeah, we had real quick, Hilary. I was going to say, we had a group on yesterday, and they wrote a tool. It's a VMware. It's part of the VMware migration, right? So if you're going from VMware to OpenShift virtualization, wherever that OpenShift vert lives, but this tool, you run it, and it basically says, hey, look, you have X amount of VMs, X amount of clusters, X amount of storage, network, compute, whatever, and it says, based off of like your source and your destination, here's how long it's going to take, right? Here's how many VMs. Here's the recommendation for, is this a migratable VM? Like, is this a pet, or is this a cattle? And it's pretty freaking dope. And so I think when you take tools like that, and then you take the HyperShift stuff and the migration things that like you were saying with MTV and stuff, all the tooling is starting to mature, right? Like like Hill said, like the thought has been there, the high level tools have been there, but like the low level tooling around like the actual getting it from point A to point B and everything in between, all that's maturing, and it's going to be amazing. And 6 months from now, we're going to be having totally different conversations about this.
Yeah, 100%.
Totally.
Yeah,
totally.
Yeah, I was gonna say, it's amazing some of the things that our customers do, and it's the nature of the job, but slightly unfortunate that we can only kind of use very broad terms. Like, our customers do cool things. Our customers run mission critical things that you unknowingly interact with across your day-to-day life. We can hand wave at this. One of these days, I gotta go figure out what we're allowed to publicly say, because honestly, some of these stories, I always consider myself like a pretty smart person, and then I see what some of these people are doing. I'm like, oh, never mind. I'm a moron. These people over here are freaking geniuses. I never would have thought about it.
Well, me as the tech sales guy over here, I'm like on the low man on the totem pole on the smart umbrella here. But it's fun to be around a bunch of smart people. I think one of my favorite things about Red Hat is we have so many smart people who are doing really cool things and being involved in really unique challenges. And I think there's a lot of neat things to be able to do. So
absolutely,
yeah, for sure. So I guess, Michael, correct me if I'm wrong, the TLDR on hosted control planes, aka HyperShift, is still OpenShift, but with more resilience and more flexibility and better cost. Does that sound right?
Yeah. I mean, I think like looking at the hosted control plane offerings, it's more resilient, it's more efficient, it's easier to manage, and it's definitely lower cost because operationally it saves you a lot of money from an infrastructure perspective. And I think most importantly, it's evolving constantly. So we're seeing a lot of evolution there. And that's something that I think is really valuable, is like, as we look to like what the future holds, and we look at the future of OpenShift and the future of our product offerings and service offerings in the cloud, hosted control planes is the future. Our ability to deliver and release new things that are important to our customers, whether that's things like carpenter support, whether that's other different technologies that are important, like supporting new AI technologies and things like that. All of that is coming in our hosted control planes offering by default. And so I think those kind of things are going to be where the future holds. And I'm excited to see where it goes, excited to be a part of it.
Awesome. Well, thank you so much for coming on and talking about
My
this
pleasure.
with our audience. Your expertise in terms of like those interactions still definitely exceed mine. Don't worry, I'll catch up. I guess we're a little bit past top of the hour, so I guess we're gonna have to wind it down. I don't have any closing thoughts. Does anybody else have closing thoughts?
I was just gonna say, like, to add on to what Michael was saying, like, you also have the ability to do the multi-arch with HyperShift, right? Where you could have an ARM control plane and then x86 workers, which it's a big deal. Like when the thing you were saying earlier about, like, you have 500 clusters or whatever it is, right? Like you start saving those like 0.5% or the 5%, that adds up.
Oh, absolutely. Yeah. I mean,
that's all.
ARM. Yeah. ARM is a great example of that. I mean, 20% cost savings approximately from a like price to performance ratio. I mean, that's a sizable amount of money. Like I always encourage people when they look at like the cost that they're actually paying. OpenShift is like this, but their underlying compute costs are this big. And so it's something that is really important to consider. You have to look at this holistically, is to say, how can I reduce my operational overhead, my operational expenses? ARM is a great example of that. Soon in OpenShift 4.22, when we release the ability to use Carpenter and AWS, that'll be really big. Being able to use heterogeneous auto scaling to bin pack, all of that is going to be, I think, really valuable. And so it's exciting to be in that, because we're talking about how do we save money, how do we better optimize customer environments, and that's a win for everybody, right? It makes everything better. So, and thanks so much for having me, y'all. I really enjoyed this, and hope you'll invite me back again sometime in the future.
Oh, 100%. 100% going to have you come back and talk. Going to have you come back and talk about something you don't like next time. I don't know what that is. But there's got to be something.
We'll figure something out.
We'll figure it out. For sure. All right, folks. Well, hey, until the next time we see you, choose your technical debt wisely, and we will see you in roughly like, I don't know, sometime after Summit. End of May, beginning of June.
Perfect.
Bye-bye.
Thanks, everyone.